Our planet is becoming lopsided. For millennia, Earth's two halves operated in tandem. Northern Hemisphere, Southern Hemisphere. They were like mirror images, reflecting seasonal rhythms. When one pole cooled, the other did too. That predictable symmetry created a stable global system. But that balance is now breaking. Scientists have observed a startling new trend. The North and the South are falling out of sync. This is not just curiosity, it is a profound signal of a planet under stress. Consequences will ripple across every continent and ocean, touching every life. This growing asymmetry is a major under-discussed sign of global change. It is driven by the uneven way our world is absorbing added heat. The Northern Hemisphere is warming at a shocking rate. The Southern Hemisphere, dominated by oceans, is responding more slowly and erratically. The story of the planet's new imbalance begins in the north. The Arctic is the epicenter of this change. It is warming more than twice as fast as the global average. This is a phenomenon known as Arctic amplification. This rapid heating is transforming the region at a breathtaking pace. Every summer, more of the bright white sea ice that once covered the Arctic Ocean vanishes. This exposes the dark ocean water below. Dark water absorbs sunlight instead of reflecting it. That absorbed sunlight heats the ocean more, melting even more ice. It's a powerful feedback loop, a vicious cycle. It's accelerating warming across the Northern Hemisphere and disrupting ancient climate patterns. On land, the vast Greenland ice sheet is melting at an alarming rate. Each year, billions of tons of ice are lost to the ocean, raising global sea level. Permafrost, the permanently frozen ground, is also thawing across Siberia, Alaska, Canada. Thawing releases vast stores of trapped carbon and methane, potent greenhouse gases fueling more warming. The very landscape of the north is changing. Rivers are altering their courses, coastlines are eroding. Warming is disrupting the polar jet stream, making weather more extreme and persistent. Lingering heat waves or frigid air plunges far south. The Southern Hemisphere tells a different, more complicated story. While the planet as a whole is warming, the signals in the south are more mixed and muted. Antarctica has not warmed as uniformly or as quickly as its northern counterpart. The sheer size and elevation of the East Antarctic ice sheet make it incredibly resilient to change. It has helped to slow the overall temperature rise in the Southern Hemisphere. Unlike the Arctic's consistent decline, Antarctic sea ice has shown more variability. Even modest expansion in some years, followed by record lows. This erratic behavior is driven by shifting wind patterns, ocean currents, and fresh meltwater from the continent's edges. The vast Southern Ocean encircles Antarctica, insulating it, while absorbing and storing enormous amounts of excess heat. Powerful winds drive upwelling that pulls cold water to the surface and mixes heat down into the abyss. However, resilience is not absolute. West Antarctica and the peninsula are losing ice faster, with warm waters eroding ice from beneath. The Southern Hemisphere is not immune, just responding on a different timescale. The slow-moving South is a sleeping giant. Well, that thought lingers. The primary reason for the growing divide between the hemispheres is their fundamental geography. The Northern Hemisphere is 39% land, while the Southern Hemisphere is only 19% land. Land surfaces heat up much faster than water surfaces when exposed to the same amount of energy. Think of how hot sand gets on a sunny day compared to the ocean next to it. As greenhouse gases trap more of the sun's heat, the vast land masses of North America, Europe, and Asia are warming rapidly. This simple fact sets the North on a different climatic path than its water-dominated southern counterpart. The Southern Ocean is unique, the only ocean flowing unimpeded around the globe, creating the powerful Antarctic circumpolar current. This current isolates Antarctica, while strong winds drive upwelling that keeps the surface cooler and shuttles heat to the deep ocean. Human pollution adds complexity, particularly aerosols, tiny particles from fossil fuels industry and wildfires, more concentrated in the north. For decades, sulfate aerosols reflected sunlight, masking some warming, but cleaner air has diminished this cooling, revealing the true heat. Meanwhile, ocean circulation that transports heat, like the AMOC, can be disrupted by freshwater from melting ice, reshuffling heat between hemispheres. Together, land, ocean, and pollutants are pulling the hemispheres apart, rewriting the planet's climate map in real time. The divergence of the hemispheres is not an abstract concept, it has tangible impacts on people's lives, livelihoods, and safety. One of the most direct consequences is on our food security. Agriculture depends on predictable weather patterns, the right amount of rain at the right time, and a reliable length for the growing season. As imbalance shifts storm tracks, some regions face more frequent droughts, others unprecedented floods, extremes that decimate yields. Accelerated melting, especially in Greenland, drives sea level rise, with regional variations that put millions in low-lying cities at risk. Chronic flooding, stronger storm surges, and eventual loss of homes and communities are a slow-moving but relentless threat. More intense heat waves raise health risks, especially for the elderly and outdoor workers, while mosquitoes and ticks expand, spreading dengue, Zika, and Lyme. Extreme events drive massive costs. Shifting fish stocks disrupt coasts, unpredictability hobbles planning. The poorest, with fewest resources, bear the brunt. The lopsided planet creates a lopsided distribution of risk and hardship. As the Earth's hemispheres continue to diverge, we can expect a future with more volatile and extreme weather. The growing temperature difference is altering the behavior of the jet stream, the boundary between cold polar and warmer southern air. A sharper gradient can energize it, but rapid Arctic warming can also make it wavier and slower. That drunken path lets systems stall, bringing prolonged heat waves, persistent droughts, or days of unending rain. If Greenland's rapid melt continues while Antarctica's losses accelerate, coasts face a double-barreled sea level threat. Freshwater influx could slow the AMOC, cooling parts of Western Europe and reshaping monsoons on which billions depend. Ecosystems are torn as seasonal clocks fall out of sync, migrations and blooms miss their cues, and populations decline. The Arctic points toward ice-free summers, but Antarctica's fate, especially West Antarctica, remains a critical tipping risk. If warming waters push it past a threshold, irreversible collapse could commit us to meters of sea level rise over centuries. The growing imbalance is a clear warning. We are pushing Earth systems into uncharted territory, where abrupt and irreversible changes are dangerously likely. The breaking symmetry between Earth's hemispheres is a planetary-scale symptom of a world thrown out of energy balance by human activity. It's not that one hemisphere is warming and the other isn't. They're warming at different speeds and in different ways governed by their geographies. Land and sea. This divergence is a clear fingerprint of anthropogenic climate change. Our impact now alters the mechanics of the climate system. The north-south imbalance signals Earth reorganizing under pressure, with immense risks. An unstable climate means less predictability. Our civilization relies on stability, agriculture, cities, now strained by volatile weather and rising seas. Models guide us, but abrupt, unexpected shifts remain possible. Uncertainty should spur precaution, not paralysis. The solution is clear: drastically and rapidly cut greenhouse gas emissions, stabilize trapped heat, and slow this uncoupling. Protect and restore natural systems that regulate climate, forests and oceans. The challenge is monumental, but the science is unequivocal, and this story involves all of us. Changes at the poles and in the deep oceans will be felt in our backyards and on our dinner tables. What do you think about this planetary imbalance? Notice strange or more extreme weather where you live. Share your observations in the comments below.